Here we are solving Pure Math 3 May 2024 paper. In part 1 of this video, we have covered question number 1 to 3. Let's look at question number 4. It's a 3-mark question. You have f of x given. We need to rewrite f of x in this format. We are going to use the double angle formula. We know sine 2x is equal to 2 sine x cos x, right? So you can write 8 as 4 times 2. So you have 2 sine x cos x here. So f of x is equal to, you need to mention the sine 2x first, this one. And then you can write it as 4 sine 2x plus 4. And then the next one, you have cos square x. This is the double angle formula. Cos 2x is 2 cos square x minus 1. Bring the minus 1 here, it becomes 1 plus cos 2x is equal to 2 cos square x. You can write this 4 as 2 times 2, so 2 cos square x. You have another 2 there. 2 cos square x is 1 plus cos 2x minus 3. So open the bracket and simplify. You'll get 4 sine 2x plus 2 cos 2x. You have plus 2 here, minus 3 here. 2 minus 3 is negative 1. Let's move on to part B. Use your answer to part A to write f of x in this form. Okay. You write odd sine 2x plus alpha plus c is equal to, look at part A, the c is negative 1, keep it as it is. You have 4 sine 2x plus 2 cos 2x minus 1. The c is minus 1. So forget about the c as of now. You can equate these two. So expand the bracket. Sine of a plus b is sine a cos b multiplied throughout by r. Cos a sine b is equal to 4 sine 2x plus 2 cos 2x. Compare the coefficient of sine 2x on both sides. You get odd cos alpha is equal to 4. Compare the coefficient of cos 2x on both sides of the equation. You get odd sine alpha is equal to 2. So from here, r square is going to be 4 square plus 2 square, which is 16 plus 4, 20. R is going to be square root of 20, which is 2 root of 5. That's the value of r. Now to find alpha, you divide them. R sine alpha divided by r cos alpha. If you divide these two equations, you'll get 2 over 4. So tan alpha is 2 over 4, 1 over 2. Alpha is tan inverse of 1 over 2. You need to use radian mode. Tan inverse of 1 over 2. They want the answer to 3 significant figures. So 0 point alpha is equal to 0.464 radians. That's the answer for part B. Let's move on to part C now. State the minimum value of f of x. Now I'm going to write f of x using the value of r and alpha. R sine 2x plus alpha minus 1. That's f of x, right? Or this plus c. So this is f of x. They want us to find the maximum value of f of x. Just look at this function. It's a translation and stretching along x-axis, which will not affect the maximum and minimum value. But the moment you multiply the function by this, the maximum becomes 2 root 5, minimum becomes minus 2 root 5. And when you put a minus 1, the graph will go down, so you need to subtract 1 from this value. So maximum value of f of x is 2 root of 5 minus 1. Now the next part says, find the second smallest positive value at which the function is maximum. The maximum value of the function is 2 root of 5 minus 1, right? Equate them. and solve and take the second value. You can cancel this, divide by 2 root 5, you will get sine 2x plus 0.464 is equal to 1. Sine inverse of 1 is 2x plus 0.464. Sine will be 1 at pi over 2 this point, but they are talking about the second point, so it's going to be 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. That's the second point. So take it is equal to 5 pi over 2 and find x. 5 pi over 2, subtract this, divide by 2. So I'm gonna store this value as a, because I'm gonna use the actual value. So 5 pi over 2 minus, instead of 0.464 the rounded value, I'm gonna use the actual value, and then divide by 2, round it to 3 significant figure. So you'll get 3.70. 3.70 is the x coordinate. That's all. Let's move on to next question. Question number 5. Find f inverse of 22. You see, it's just a 2-mark question. Don't sit there and find the inverse function. Think about this way. This is 22 now. There is some value here is mapped onto 22, right? So now they want you to find f inverse of 22. So this input will be in this form. Only thing, we don't know the value of x. That's what we need to find. So just equate the function 2 plus 5 ln x is equal to 22. Make x as a subject. You will get 20, 2 goes there, 20, 20 by 4, ln x is equal to 4, x is equal to e to the power 4. That's all. That's the easiest way to do it. Let's move on to part B. Use differentiation to prove that g is an increasing function. Let's take g, 6x minus 2. G is equal to 6x minus 2 divided by 2x plus 1. We are going to apply the quotient rule. So g dash of x is equal to, keep the denominator as it is, differentiate the numerator minus, keep the numerator as it is, differentiate the denominator, divided by v square. I am applying the quotient rule. vu dash minus uv dash over v square. This is u and v. So when you simplify this, you will get 12x will be cancelled. You will get 6 plus 4, 10 over 2x plus 1 whole square. That's g dash of x. In g of x, the domain is this. X take all the positive numbers. So definitely you need to write 2x plus 1 whole square is greater than or equal to 0 for all x greater than 1 over 3, right? This will always be positive. So definitely this whole thing is always be positive. So I need to write therefore g dash of x is equal to 10 over 2x plus 1 whole square is greater than 0 for all values of x. So if the first derivative is greater than 0, the g of x is an increasing function. That's how you write the conclusion. Part C, find g inverse. We'll take g of x first, which is this function given here. This is g of x, 6x minus 2 by 2x plus 1. G of x is equal to 6x minus 2 divided by 2x plus 1. You can replace g of x by y and make x as a subject, or straight away make x as a subject. 2x plus 1 is equal to, 2x plus 1, bring it here, times g of x, or you can replace g of x by y is equal to 6x minus 2. So it's 2xy plus y is equal to 6x minus 2. Bring this term here, y here. We'll get 2xy minus 6x is equal to minus 2 minus y. So multiply through it by negative sign, so you will get 6x minus negative 1. 6x minus 2xy is equal to 2 plus y. Take x as a common factor. 6 minus 2y is equal to 2 plus y. So x is going to be 2 plus y divided by 6 minus 2y. So straight away you can write g inverse of x is equal to 2 plus x, don't put y now, 6 minus 2x. But to get the full 3 marks, you need to find the domain of g inverse, which is the range of g of x. For this type of functions, I have explained in one of my videos, there is a shortcut to find the range using the domain given. The domain given here, look at g of x, the domain is x is greater than 1 over 3. X is greater than 1 over 3. So what is the shortcut? Sub in the point here in the place of x. 6 times 1 over 3, you will get 0. And then take the coefficient of x divided by coefficient of x, you will get 3. So straight away, that's the range. 0 to 3 is the range which is going to be the domain of g inverse. That's all. Now find the range of fg. We have the function f of x is equal to 2 plus 5 ln x, and the domain is this. And we have g of x is equal to 6x minus 2 by 2x plus 1. The domain is x greater than 1 over 3, and the range of this function is 0 is less than g of x is less than 3. That's a range. Now when they ask you to find the composite function fg, how do we usually calculate fg? We write, let's say we have fg of x. We find g of x first. That's going to be the input of f of x. In other words, the range of g of x is going to be the input here. The range of g of x is this 0 to 3. See, so these numbers will be the input of f of x now for this composite function. I hope you understand what I'm saying. So now the input of f of x is 0 to 3. The f of x is this function. Now the domain of f of x is 0 to 3. So if it's 0 to 3, what would be the range of f of x? If you look at the graph, this is ln x with the x-intercept 1. Even if you multiply by 5, it's just a stretching. And then plus 2, you need to move the graph upwards. This is the graph. 2 plus y is equal to 2 plus 5 ln x. So when you take the x values from 0 to 3, this is x-axis. When you sub in 3, you will get 2 plus 5 ln 3. That's the y value here, right? So I'm going to highlight the domain now, 0 to 3. The corresponding graph for this domain is this. So it takes all the values below. So the range of fg is less than 2 plus 5 ln 3, because that's this value, and the function takes all the value below this. That's just a 2-mark question. Let's look at question number 6 now. We have a figure given, and figure 3 shows sketch of part of the curve with the equation y is equal to square root of this. L shown in figure 3 is a normal. The line L is the normal. Use calculus to show that this equation is this. So basically they want you to find the equation of the normal. We have learned this in pure math 1. We are going to apply the same method, but when it comes to differentiation, we need to apply chain rule. So take it as y is equal to 4x minus 7 to the power half. When you differentiate it with respect to x, half x power half minus 1 times, differentiate 4x minus 7, you will get 4. You can write this as 4 over 2 is 2 divided by square root of 4x minus 7. Now the slope is dy over dx at P of 8 comma y. In dy by dx, replace x by 8. So it's going to be 2 divided by square root of 4 8s are 32 minus 7, which is 2 over 5. That's the slope of the tangent. So slope of normal is the negative reciprocal of this. That's all. We have a point, we have a slope. You can write the equation straight away. Y minus y1 is equal to slope times x minus x1. Multiply throughout by 5, you will get 5y minus 25 is equal to minus 2x plus 16. Put everything on side, you will get this equation, but something is wrong. We don't get 58. Why? Because we should use minus 5 over 2. I made a little mistake here. It's minus 5 over 2. So you will get 2y minus 10 is equal to minus 5x plus 40. Put everything on side. 5x plus 2y minus 50 is equal to 0. That's what they want. Part B says use integration to find the area or this area. We have the equation of the curve square root of 4x minus 7. We have the point 8 comma 5. So when we integrate this curve from this point to this point, we don't know this point, we are yet to find the x-intercept, to 8, we will get this area. And then there is a triangle here. We need to find the area of the triangle and then add them. That's what we are going to do now. How to find this point? We have to replace y by 0 to find the x coordinate. So when you replace y by 0, 0 is square root of 4x minus 7. So 4x minus 7 is 0, x is 7 over 4, this point. And we know this x coordinate is 8. So first I'm going to integrate the function from 7 over 4 to 8. So integral 7 over 4 to 8 square root of 4x minus 7 dx. How to integrate a function in the form of a linear function, power n? Just put 4x minus 7, just a normal integration, power half plus 1 divided by half plus 1, but times 1 over the coefficient of x. 7 over 4 to 8. 3 over 2 times 4, it's going to be 6. I'm going to keep the 6 outside. Sub in the upper limit. So you'll get, when you sub in the upper limit, 4 8s are 32. 4 8s are 32 minus 7. 32 minus 7 is 25 power 3 over 2 minus. Sub in the lower limit. 4 cancel, 7 7 0. So we'll get 5 cube 125 over 6 if I'm not wrong. 25 is 5 square, 2 cancel, 5 cube is 120. So therefore the total area is equal to 125 over 6 plus the area of the triangle. How to find the area of the triangle? We know the equation of the line already, we calculated here. 5x plus 2y. 5x plus 2y minus 50 is 0. To find this point, you replace y by 0. So you will get, when you replace y by 0, it's better to show all this working. 5x minus 50 is equal to 0. X is equal to 10. This is 10. And height is the y coordinate of the point, so we can find the base is 10 minus 8 2, height is 5, so it's basically half times base times height, which is 5. So 6 5s are 30. 155 over 6 square units, that's the area.